Al Gore explains how global warming works in An Inconvenient Truth. Leonardo DiCaprio, along with a bunch of scientists and engineers, talks about solutions to it in The 11th Hour. At this point, the greenhouse effect is not a scientific problem of not understanding why it's happening, and it's not an engineering problem of not knowing how to stop it. The two remaining obstacles are educational and political. The public not learning the science, and political decisions not being made in a way that results in a solution. That means the remaining obstacles are psychological. So let's back up and start from the beginning of global environmental science. Exponential growth in a finite system was the math that began the study of the global environment. This is how some scientists discovered some connections among math, ecology, and economics. In 1968, Dr. Paul Ehrlich published The Population Bomb. That was also the year Dr. Aurelio Pecci convened the Club of Rome, and in 1972, they published their discoveries in The Limits to Growth. Exponential growth is a big blind spot we have in our natural perception of the world. Here's an experiment. Imagine setting an ordinary sheet of printer paper on the floor. You now have a stack of paper that's about 1/250th of an inch high. Now set another piece of paper on top of it. You've doubled the height of the stack of paper. Now, set two more sheets of paper on top of the first two, and you've doubled the height of your stack of paper again. You still can't measure the height of the stack with a ruler. Now, use your intuition and take a guess. If you double the height of the stack of paper 49 more times, how tall will it be? Just make a rough estimate of something that feels like the right answer to you. Some people guess a few inches. Some people guess 3 feet. Some people guess 10 feet. Some even guess a mile. The answer is, it'll burn up in the sun before you get that far. As biologists already knew, population grows at an exponential rate. What Dr. Ehrlich realized was that if every woman on Earth had 4 children and raised them to adulthood, our population size would double every generation. With it, our use of resources would double. The Earth isn't infinitely large, so exponential population growth can't continue indefinitely. But exponential growth starts out slow and then goes completely out of control. So people can't depend on their natural perceptions to tell when to stop having so many children. The Club of Rome discovered that factories were also being built at an exponential rate. Some factories are machine shops, which produce the equipment for more factories. That meant our per capita consumption of natural resources and our per capita generation of pollution were also increasing at exponential rates. In 1968, the president of every government on Earth was depending on his intuition to make his economic plans for the future. No government on Earth had a Department of the Environment. Today, because of these 2 books, every government on Earth has a Department of the Environment. Unfortunately, we still don't have publics that are well enough educated to be able to tell what the Department of the Environment is supposed to be doing. So, when a new president appoints his best drinking buddy to be Secretary of the Environment, who's going to notice? The basic problem that Dr. Ehrlich and the Club of Rome discovered was that The environmental crisis was being caused by people's actions having long-term effects on the world that they couldn't perceive as well as the short-term effects. It happens to you every time you drive a car. You can see yourself moving faster than you could if you were walking, and you can see that it lets you travel further, and you can see that it lets you carry more cargo. But you can't see the carbon dioxide it gives off, because CO2 is colorless and odorless. You can't see carbon dioxide building up in the atmosphere, and you can't predict what effect it will have on the climate in 20 years from now. This is what made consilience necessary. The divisions between fields of science exist for the same reason the divisions between any field of study exist. Because information is categorized according to how people perceive it to fit together. That's a humanocentric approach to science. That means it's a failure of science because human perception is getting in the way of objectivity. But how else can we study science without using our perceptions? Consilience depends on all branches of science being connected to each other and to other fields of study by what are known as first principles. These are rules that have been discovered to apply universally to an area of study. The periodic table of the elements is a collection of first principles. Unifying branches of science by first principles depends on people discovering perspectives they can use to interpret the information in terms of two or more fields simultaneously. That means consilience is basically a philosophy of science, because it doesn't depend on discoveries you memorize, but on discovering ways to interpret information that will fill in our blind spots and produce reliable results. Exponential growth in a finite system was one first principle because that connected mathematics to ecology and economics. A lot of branches of science were already connected to each other, like chemistry to physics. The unification of science was achieved by the discovery of four more first principles. Chemistry has been connected to biology, biology has been connected to psychology, and ecology, which is a branch of biology, has been connected to chemistry, physics, and economics. Politics had already been connected to economics as a pattern of decisions being made about how resources would be used. These five first principles covered the availability of resources and how people make decisions, so all of them connect to politics. These four new first principles are all different manifestations of two mathematical laws, entropy and stability. Change makes things spread out. Whenever you have a large group of things, like molecules, cells, people, or ideas, the more changes you introduce to the group, the more different results you get. The soles of your shoes are thinner now than they were when they were brand new, because with every step you take, you're adding friction to the bottommost molecules. That change you have introduced has spread the molecules of your shoes out into a trail of microscopic dust that follows you everywhere you go. Once upon a time, the molecules in your shoes were concentrated into one place, but the more friction you add, the more places those molecules end up. Out of all the possible results of changes, some create patterns that resist further change. That's why some kinds of rocks erode more slowly than others. And a few patterns not only resist change, but also create more patterns. And that brings me to evolution.